We use it when the binomial, the first term is 1 and it has another thing. What should we say? You just okay, so you okay, so this marker is better to the power n. So this is a general formula they have. So that one is, the formula goes this way: n to the power n minus 1. So it seems that the first term is always 1. That's what they are saying. Because when we solve the first one, you could see that the final answer for the first term was still 1. And the second term is n times x. That's the exponent times the x. So the third term becomes n into bracket n minus 1 all over 2 factorial x squared. That's the third term. Then the fourth term will be n into bracket n minus 1 n minus 2 all over 3 factorial x cubed. So the fifth term becomes, it goes on and on to the last term. Okay, this is the formula we are going to use. So this is it. So we are going to use 1 plus x to the power 5. Let's try it and see. So it becomes 1 plus, that's the first term. So the second term becomes 5 times x. That's the second term. Then the third term is 5 minus 5 minus 1 all over 2 factorial x squared. The third term becomes 5 bracket, the fourth term, 5 bracket 5 minus 1, 5 minus 2 all over 3 factorial s cubed. The fifth term becomes 5 bracket 5 minus 1, 5 minus 2, 5 minus 3, all over 4 factorial x to the power 4. Then the sixth term, that's the last term, becomes 5 bracket 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4, all over 5 factorial x to the power 5. So you can see that here the factorial was 1 factorial, here was 0 factorial. 0 factorial and 1 factorial are the same thing. 0 factorial is 1, 1 factorial is 1. So here it goes 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial to the 5 factorial. Then the exponent for here was 0. You can see it, x to the power 0 is 1. So it started increasing. So here will be what? 1, 2, 3, 4, 5. You get it? So these are the tricks in the formula. So it started 1. And the next term is the n times the x. The third term becomes n into bracket n minus 1 divided by 2 factorial x to the power 2. So the fourth term becomes n into bracket n minus 1, n minus 2, 3 factorial x to the power 3. Then it goes on and on and on to the last term. That's the last term. So any additional term, you just be introducing a new open bracket, then you reduce it by the subsequent number. So here was 2, so the next number should be what? 3. So here to the last one ended at 3, so we should introduce a fourth one. So that's how you do your expansion. And basically this will give you 1, because I said 0 factorial is equal to 1. We have the proof though, but it's not necessary. So 1 factorial 2 is 1. So 5 times, 5x divided by 1 is still 5x, so here becomes 5x. That's why it says 1 plus nx. So here becomes 4. 4 times 5, 20, 20. 2 factorial. Factorial means 2 times the number that precedes 2. So like 2 times 1, you get it, is 2. So we do it to 1. So if you see 3 factorial, it means 3 times 2 times 1. Do you get it? So 4 factorial will be 4 times 3 times 2 times 1. That's how we do it. So this basically 24 here. So here we divide here by, here becomes 4. 4 times 2, 4 times 5, 20. 20 divided by 2 is times 10x cubed. Because, what is it? Yeah. So here becomes 4. Then here will be 3. 4 times 3 times 5. 4, 5, 20 times 3, 60 divided by 6 is still 10. Okay, 3 factorial is 6, so divided by 6 is 10. So 10x cubed plus, here will be 6 times 4, 24. So here to 60 times 2, 120. 120 divided by 24, I think is 5. Yeah, 5. It should be 5. 4x plus, here will be 120. 120 divided by 5. And 5 factorial will be is 120. So 120 divided by 120 is 1. So 1. So 5 x to the power of 5. So now you have the expression. You have the expansion. Sorry. So now that you have the expansion, to find x, you can still use the method I showed you by comparing this to the expansion. So you get 1.02 to the power of 5. Then you compare. So by comparison, 1 is 1, x is equal to 0.2 to the power 0.2. So you can say x is equal to 0.2. Sometimes they can give you 2 to the power 2 points, maybe 2 to the power 5, and they will say find x, expand the function and find the value of this. So still, since here is 2.2, when you are solving such a question, you can, first of all, you can't use this to solve a question like this. So before you can do that, you should first factorize out 2 to the power 5. And when you factorize out 2 to the power 5, you'll be left with 1.1 to the power 5. Yeah. So now, therefore, now you have 2 to the power 5, and here is 1.1 to the power 5. So instead of x being 0.2, now it is 0.1, because when we factorize it out, we'll get 1 plus 0.1 by comparison. So now x is no more 0.2, it is 0.1. Do you get it? So when you put, instead of putting 0.2 in the x, you put 0.1 in the x. When you are done, then you multiply the final answer by 2 to the power 5, so that you get for 2.25. 2.2 to the power 5. But if it is 1.2 to the power 5, now you can use this method. So after, when you get all of them, you can use this method. When you get here, this is how you do it. But let's see, 1.2 to the power 5. You just break it down. 1.2, 0.2. So you split it. So you know that 1 plus 0.2 will give you 1.2. So therefore, here is the 1 and here is the x. So therefore, x is equal to 0.2. But in situations whereby they give you 2.2 from the onset, since you use this method, you use 1 plus x to the power 5 to solve the question. You should factorize 2 out so that you'll be left with 1.1 to the power 5. So when you factorize the 2 out, since it is to the power 5, this 5 comes out. So you get this. So now it has changed from 2.2 to 1.1. So by comparison, you can compare 1 plus 0.1 to the power 5. So therefore your 1 is here and the x becomes 0.1. So now instead of using 0.2 in the initial example, we are going to use 0.1. If the question was given, find 2.2 to the power 5. Sometimes they will say find 0.98 to to the power 5. So with 0.98, you know that it is 1 minus 0.02. That will give you 0.98. You know that 1 minus 0. So this one you should know. 1 minus 0.92. Sorry. 1 minus 0.02 will give you 0.98. So when you subtract, after you can say by comparison 1 is equal to 1, then the x, so plus x. So x is equal to negative 0.02. So you use negative 0.02 to find for this. And when it is 2.2, you use the 0.1 because we factorize the 2 out. And with that one, I'm saying that when you get your answer, when you get your answer for this 10, multiply it by 2 to the power 5 because it is multiplying the 1.1 to the power 5. So it's like we splitted this to this. So when we are done with, when we use this to find it, we multiply it by this so that we get that for 2.2 to the power 5. And if it is 0.98, you just split 0.98 into 1 minus 0.02 and you compare. So the x becomes minus 0.2. Sorry, minus 0.02. Then you insert it into the equation. You find the answer for x. So for instance, they can give you 1 plus x to the power 5. And they'll tell you find the coefficient of x to the power 3. Find the coefficient of x to the power 3. Probably you can do the expansion. You know it's 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the power 4 plus x to the power 5. So the answer is this. Alright, so that therefore the coefficient of x to the power 3 is 10. But when there are more complicated questions, like when they tell you to find maybe to the power 17 and they tell you to find the 16th, you can't do all the expansion to get the 16. You need to maneuver your way out. So that's what I want to teach you now. So we find the coefficient power 3. So to do that, that's why I said this formula, it should always be with you. You use this formula. This is just the combination aspect of it. So I'm telling you that the A is the 1. Always the number at this portion is the A. And the one at the latter is what? Your X. Okay, so the one at this portion is always A. And the one at this side, the other side, is the B. Okay, is the B. So 1 is A and X is what? B. So if we want X to be 3, then we should make sure that the B2 is 3. Because B is equal to X. So if you want X to be 3, then B should be also 3. So N combination R should be, N combination R. Let's use the values. So 5 combination 3. If B is 3, because X and B are equal. So since X and B are the same, here will be 1 to the power 5 minus 3 x to the power 3. So this is it. So here 5 combination 3 is 10. Now we have it. That's the coefficient. I told you this, we are just looking for the coefficient. So that's it. That's what we are looking for. But let's see. 1. Because 5 minus 2 is 2. Sorry, 5 minus 3 is 2. So that so 1 to the power 2 is still 1. So times x to the power 3, and we get 10x cubed. So this is the coefficient we are looking for. So from the probably they will tell you to find the term itself. Okay. So it's either they will tell you to find the coefficient of a particular term or the term itself. So with this expansion, we know maybe this is the expansion. They're giving you this expansion, and they tell you to find maybe the second term. So with this, you should know the number of terms. That's the first thing. And I told you the number of terms is n plus 1. And you should know the arms, the index number for each term. So you know that the r, the first term, r will be what? 0. So its index number is 0. The second term's one will be what? 1, right? And the third term will be what? 2. This one looks more easier. But when we go into more complicated examples, it becomes tricky. Okay. So x to the power 6. X, this time around, the x is at this side, not this side. So with this, you know that down the x is the a. Do you get it? And they are telling us to find x to the power 4. So now the x is the a, and the 2 is the b. So we can say that if we want x to the power 4, we should equate it by, we replace the x by a. So we replace a by x in the formula. So it becomes x n minus r. Okay. So now you know this is, I'm saying that the x is now at, unlike this one, the x is now at the a's portion of the binomial function. So now you can replace x by a. Do you get it? So they are telling us to find x, the coefficient of x to the power 4. We are finding the coefficient of x to the power 4. So therefore, we can replace the x by a. Sorry, a by the x in the formula. So we just take only this. Then we replace the a by x. Okay? And there is something in indices. When the bases are the same, we equate their exponents. So we can equate 4n minus r. And we know the n to be 6. So 4 is equal to 6 minus r. So therefore we can bring this one here, then take this 4 to this side. So we get r being equal to 6 minus 4. So r is 2. So when r is 2, we'll get x to the power 4. That's what it means. So we can say 6 combination 2. A 6 minus 2, B 2. So therefore, we know our 6 combination 2. So we know this side to be 15. So we know our a to be, this side will give us 4. And we can replace the a by x. So now you know we have our x to the power 4. And since the b is 1, we times 1 to the power 2. So now the 10 is 15x to the power 4. So regardless where they will tell you what to find, you can find the x. You can find the 10 and you can find the coefficients. What I'm trying, you should know the position of the 10 in which you are finding it. Using the basic method, this is how you split it when you have x cubed. It means this multiplying itself 2 times. So this x times x will give you x squared. Then x times 1 over 2x will give you half. Because x will cancel the x, you'll be left with half. X times, 1 over 2x times x will still give you half. Because they will cancel each other. And here, when you multiply, you get 1 over 4x squared. So this side will add up, you get 1. So x squared plus 1 plus 1 over 4x squared. So this is the 10, which is independent of x. Okay, so independent of x means that the 10 has no x variable. So that's what we are coming to do basically. For the term which is independent of x. The term which is independent of x. So this is it. This is it. This is it. So you know this is the A side and this is the B side. So it becomes, when we are using the formula, this becomes x and this becomes the whole of b. So we can say n combination r is equal to what? X, that's the a, n minus r. So this is the x. Then dot b, and the b can be replaced by 1 over 2x to the power r. So I said this whole side is b. Okay, so this is it. And we are finding the term that is independent of x, which means that the x value should be 0. X should be 0. So we don't need combination. So we take the combination out. Then we'll be using the x's. The x's. That's what we are interested in. So from here we can say x n minus r. Then this side we can see dot 2x times r, because indices, when you have any number 1 over any number, you can write it as the inverse of that number. So you can write it this way. So since we have this, you can write it as 2x minus 1 times r. So since we have this, now we have s to be the basis. So here we can equate them to x to the power 0. So since we have the same basis, like n minus x here, 2x and x, we can equate their exponents. So it becomes n minus r plus minus 1 times r being equal to 0. And we know our n to be what? 2. So 2 minus r minus this and this will give you r is equal to what? 0. Minus 1 times r will give you minus r. So you get 2 minus 2r being equal to 0. We take r to the opposite side, we get 2 being equal to 2r. We divide it by 2, we divide it by 2, so that we get r as 1. So it means that when r is 1, we will get a term which is independent of x. And you know the number of terms should be 3 because the power is 2. So the middle term will give you that, and this is the middle term. So here is when r is 0, when r is 1, and here is when r is 2. So you can use the combination formula to find it. So 2 combination 1. 2 combination 1. What is the a? A is x 2 minus 1. And what is the b? 1 over 2x to the power 1. So this time around, you just put everything in the formula and you find it. So it becomes 2 combination 1 is 2. Wow, no 1. So 2. X, so yeah, 2 minus 1 is x. Wow. Then times 1 over 2x, because anything to the power 1 is still the same. So this will cancel this. Then we get 1. So that's the term which is independent of x. So basically, this is the whole idea of binomial theorem, and it has been summarized and made easy. We'll try and solve more questions on it